In this video, we're going to learn about irrational numbers. If you recall, probably from middle school or so, irrational numbers are simply numbers that are not rational. And we did a project, a coloring project, right? So if you look on your wall, you should be able to find out where the rational numbers are in the real number system. And they're not rational because they cannot be written in the form of A over B. Um, for example, if you do have a form of A over B, you would have 1/2, which is zero point 0.5, and that will be rational. And you can have 1/3, that's 0.333 endlessly, and sometimes you see a zero point 0.3 bar. And those are all rational. And an irrational one cannot be like root 2, becomes 1.414, some other numbers, but there's no pattern, there's no repetition of a single number or a pair of numbers. So there's no pattern. Everything after 414 is all random. So that's why they cannot be written in the form of A over B. And the square roots, which is really important, what we just talked about, root 2, the square roots of numbers that are not perfect squares are irrational numbers. So root 3 is not a perfect square, 2 is not a perfect square, but 4 is a perfect square. So square root is irrational because 3 is not a perfect square. Okay? So that's the definition of irrational numbers. They're square roots of a number that's not perfect square. Now, because of that definition, we should really know a string of perfect squares. So obviously 1 squared would equal 1, 2 squared would equal 4, 3 squared would equal 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, and 10 squared is 100. So that's all the perfect squares before 100, and any number in between. So if I have between 1 and 4, I have 2 and oops, 2 and 3, that's not a perfect square, so root 2, root 3 would be irrational. Between 4 and 9, I have 5, 6, 7, 8. All of these are irrational, so on and so forth. Okay? So let's look at some examples. Determine if the following numbers are irrational or rational. Root 25 would equal 5, right? Because that's, if I have to rewrite it, 25 is 5 squared. Notice that with square root, there is an invisible 2 there. So whenever there is a power of 2 of a number, perfect square, the square of a number, and the root 2, these two would cancel, and the base 5 would come out. And that gives us our final answer. And second one, 50. Notice 50 is between 49 and 64, not a perfect square. So if I have to rewrite it into a perfect square, I would rewrite it as 2 times 25, and 25 can be rewritten as 5 squared. Now this power of 2 and this invisible 2 with the root gets canceled. The base can come out, but notice that even if the 5 comes out, I still have the 2 left. So that's the final answer. And root 2, as we said, that's irrational, right? So this one is also irrational. This one is rational. And 2 is not a root. 2 obviously is rational. It's a real number. It's rational. 5 over 8 is in the form of A over B, and therefore this is rational. And this one is a little harder, but notice we can rewrite this into 12 squared over 3 squared. And if I rewrite that fraction, it's also 12 over 3 whole thing squared. And again, this power of 2 and the invisible root 2 gets canceled. The base comes out, and that's already a rational number, but 12 over 3 is 4, so that is rational. Okay? But how do we estimate the square root? We touched upon it quite a bit earlier. We say to estimate the square root of a non-perfect square. First, find the two consecutive perfect squares that the non-perfect square is in between. Consecutive means 2 in a row, or 3 in a row. 2 or more, I should say. 2 or more in the, so 2, 3, 4, 5, that's consecutive. 2 and 3, 5 and 6, 78 and 79, that's called consecutive. So let's take the previous example. Let's estimate 50. Square root of 50. So we said that, if you take all the square roots before 100, it's 1, 4, 3 squared is 9, then it's 16, 5 squared is 25, 6 squared is 36, 7 squared is 49. We're getting close. I need 50, right? 7 squared, 8 squared is 64. So this is all the numbers squared, all the numbers before 8 squared is from 8 to 84. Notice that 50 would be somewhere in between, slightly bigger than 49, quite a bit less than 64. And also notice 49, I can rewrite this. I'm going to write it here. 49 is 7 squared, square root of 7 squared, and that's square root of 8 squared. And so in other words, this is 7, this is 8, the final number, right? So we're saying, so because of that, we can say that we can take the, here we go, take the square root of each number, which is what we did here with the green ink. And now we can draw the conclusion that root 50 is slightly greater than root 59 and quite a bit less than root 64. Therefore, it's slightly greater than 7 and quite a bit less than 8. So we can draw the conclusion that the root 50 is between 7 and 8. And if you take your calculator, like we said, it's slightly bigger. It's probably, if I have to, it's about 707, somewhere around that neighborhood. So that's how we do it. Again, first step is to find the closest perfect squares right before and right after. And then you just know that it's bigger than the lesser number and less than the greater number. And then you solve for the square root, and that's your answer right there. Okay? So let's look at some examples. I have root 5. Like I said, the perfect square right before 5 is 4. And the one after that, 6, 7, 8, these are not perfect squares. 9 would be the next. So then I just put it in between. I say it's less than root 9, greater than root 4. And then I take their square roots. And that's how I come up with the final answer. And you can also use your calculator and do this. Okay, it comes out to be a 2.24. Now, in this practice, I don't want you to use your calculator until the last step. And before you do that, I want to see, I want to see this is the final answer that I want to see. If you leave it there, I'm okay with it. But if you get to 2.24, that's even better. You will lose point if I don't see this inequality. Um, but you, but I won't take points off, obviously, if you give me the square root. I'm sorry, the approximate decimal point. So same thing here, root 3. Root 3, if you think about it, before 3 is, I have 1 and 2. 2 is not a perfect square, 1 is, right? And you know what, this time, let me just work with a number under the roots. So I'm looking for perfect square. So the number after 3 will be 4. 4 squared is, I'm sorry, it's, no, let's do this, sorry. So I'm looking for root 3, and I'm looking for the root that it's greater and less than. So the one before that, after 3, it would be 2. Root 2 is irrational because 2 is not perfect square. 1 is rational. 1 is a perfect square. And then the one after 3 is 4. See how I do that? And then I take the square root. Root 1 is 1, and root 3 comes down. Root 4 is 2. That's my final answer, right? And if you want to use your calculator, you can. And this comes out to be root 3 is 1.41. And let's go back to root 10. Same thing. I put root 10 in the middle, write my inequality, write my square roots. So what do I fill in there? I have before 10, the number less than 10, but it's a perfect square, would be 9. The number greater than 10, 11 is not a perfect square. 12, 13, 14, 15, they're not perfect square. 16 is a perfect square. And then if I take my square root, I will come out to be root 10 is between 3 and 4. And if you use your calculator, this I think it's about 3.16. Okay, so that's it. It's about estimating the perfect square right before and right after the irrational number. So in summary, I think we had already done this, haven't we? This is just some more practice. So use this and practice on your own, and finish the homework page, and that counts as 5 points. Thank you, guys.